Welcome to the darkest corners of our planet. This is the deep sea, a world almost entirely unknown to us, a realm of perpetual twilight and then absolute blackness. Life here looks strange. It behaves in ways that defy our understanding. It breaks the rules we thought were universal. Here, in the crushing, silent dark, the story of life takes a turn into the bizarre, the beautiful, the utterly astonishing. Every creature is a testament to the sheer, stubborn power of existence. Forget what you think you know about necessities for survival. On the sun-drenched land in the shallow seas, life is fueled by light and warmth. But descend deeper, and the sun's rays can no longer penetrate the water. The world becomes cold and profoundly dark. The pressure above becomes immense, a force that would crush any familiar land animal. Yet life does not just exist here. It thrives. A theater of odd, ingenious solutions. Adaptations so extreme they seem like science fiction. In the deep, some animals make their own light. This living light, bioluminescence, is a cold, efficient glow. It wastes almost no energy, perfect for a world without sun. The anglerfish turns light into a trap, a tiny, waving lure. Curious prey drifts closer, then jaws close, effortless and final. Others speak with light. Firefly squid wear hundreds of photophores, switchable like pixels. They attract mates, signal partners, and steer as a group. When danger nears, patterns explode, flash, fade, misdirect. Predators stall, the night becomes noisy with light. Down here, illumination is currency, language, and weapon. But light is also a shield. When attacked, some shrimp and jellyfish release a brilliant cloud of glowing particles, a bioluminescent burglar alarm that momentarily blinds and distracts the aggressor. The predator is left confused by the sudden flash, giving the prey a precious few seconds to vanish back into the gloom. In the deep sea, light is a multifaceted tool. It is a lure. It is a language. It is a warning. It is a cloak of invisibility. It is, in essence, the key to life and death, a world of living lights bodies built to withstand impossible forces, senses we can barely comprehend. Evolved in isolation for millions of years, crafting unique strategies to find food, to find a mate, to simply survive. A frontier that holds more mysteries than the surface of the moon. The crushing depths of the ocean present an almost unbelievable physical challenge. The pressure of the water increases relentlessly with every meter you descend. For every 10 meters, pressure rises by 1 atmosphere. At 1,000 meters, the force is over 100 times surface pressure. Some animals live deeper, beyond 8,000 meters in dark trenches. The pressure there is immense, like 50 jumbo jets stacked on you. So how do they survive? By reimagining what a body can be. No rigid skeletons, no gas-filled swim bladders. Instead, soft, gelatinous bodies made almost entirely of water. No voids to collapse. Internal pressure equals external. The Mariana snailfish is a champion here. Ethereal, pale, tadpole-like, translucent skin. It seems built to yield to pressure, not resist it. Scientists discovered special molecules, enzymes and proteins, called piezolites, that protect cells and keep proteins functional under pressure. Life down there is shaped by scarcity. Slow metabolisms conserve energy. Marine snow, rare morsels drifting down. Ambush predators wait days or weeks for one big meal. In the hidden deep, every movement is calculated, every calorie precious. In a world where sunlight is a distant memory, sight is of little use for hunting or navigation. And so, life has evolved an extraordinary array of alternative senses to perceive the world. Some animals use sound in a highly sophisticated manner. Dolphins, many-toothed whales, which often dive deep to hunt, use echolocation. They emit a series of high-frequency clicks and then listen for the echoes that bounce back. These echoes create a detailed acoustic picture of their surroundings, allowing them to pinpoint the exact location, size, and even texture of their prey. It is a form of biological sonar. Many fish, from sharks to the smallest minnows, possess a remarkable sense organ known as the lateral line. This is a faint line that runs along each side of the fish's body, composed of a series of pores connected to sensitive nerve cells. The lateral line detects tiny movements and pressure changes in the water. It can feel the subtle vibrations created by a struggling shrimp or the pressure wave of an approaching predator. This distant touch allows fish to navigate with precision and react to threats they cannot see, feeling their way through the dark water. Sharks possess another sense that seems almost supernatural: electroreception. They have a network of special pores on their snouts, called the ampullae of Lorenzini, which can detect the faint electrical fields generated by the muscle contractions of other living things. This allows them to find prey that is completely hidden from view. A flounder buried in the sand, perfectly camouflaged, is still detectable to a shark, which can sense the weak electrical signature of its heartbeat and breathing. It is an incredibly effective tool for a hunter in the dark. Other long-distance travelers, such as sea turtles and some whales, appear to use the Earth's magnetic field as an internal compass. This magnetic sense helps them navigate across vast, featureless expanses of ocean during their epic migrations, returning to the very same breeding grounds, feeding grounds year after year. These senses are not just simple tools, they are masterpieces of evolution. They paint a rich, detailed portrait of a world that would be utterly blank to our own eyes, allowing life to flourish in the eternal night of the deep. The adaptations required for life in the deep have produced a cast of characters stranger than any fiction. Consider the giant squid, a legendary creature of the abyss. For centuries it was known only from sailors' tales and the occasional carcass washed ashore. Now we have seen it alive in its natural habitat, a colossal hunter, with eyes the size of dinner plates, perfect for capturing faint bioluminescent prey. Its long tentacles, armed with powerful suckers, can snatch victims from a distance in the silent darkness. Then there is the vampire squid, not a bloodsucker. It lives in the oxygen minimum zone. When threatened, it pulls its webbed arms up and over its body, the pineapple posture, enveloping itself in a dark cloak, revealing intimidating-looking but soft spines. The gulper eel, or pelican eel, mostly mouth. Its enormous, loosely hinged jaw can open wide enough to swallow prey, much larger than itself. When it finds a meal, its mouth and stomach can stretch to accommodate the catch. A critical adaptation where food is scarce. You can't afford to pass up a meal. The rest of its body is little more than a long whip-like tail, sometimes tipped with a light-producing lure. Even familiar animal shapes are changed by the deep. Deep-sea sharks, like the goblin shark, have elongated snouts packed with electroreceptors, jaws that can protrude dramatically to snatch prey. Sperm whales, champions of the deep dive, holding their breath for over an hour as they hunt for giant squid thousands of meters down. Each of these animals tells a story of adaptation. Life, when pushed to its limits, becomes wonderfully and beautifully strange. The journey into this abyss is a journey into the heart of biological innovation. For all our curiosity, we still know remarkably little about the deep sea. The ocean covers over 70% of our planet's surface. The deep sea is the largest habitat on Earth by a vast margin. Yet we've explored less than 5% in any detail. New species are discovered on nearly every expedition. New behaviors are observed that challenge our theories. The deep sea remains Earth's last great frontier, a place of profound mystery and endless discovery. We are only now developing the means to truly explore it. This new age of exploration is driven by incredible technology. Remotely operated vehicles, or ROVs, are our eyes and hands in the abyss. Tethered to a ship, these unmanned submarines can descend to depths humans could never withstand. Equipped with high-definition cameras, powerful lights, delicate manipulator arms, they let scientists observe, record, and collect samples from the seafloor. They can stay submerged for days, patiently watching life unfold in a world unseen by human eyes. Alongside ROVs, autonomous underwater vehicles, AUVs, are mapping unknown territories. These untethered, pre-programmed robots swim vast transects, gathering data on water temperature, chemistry, and the contours of the seafloor. They are creating the first detailed maps of what was a blank space. New camera systems capture the true colors of bioluminescence, while sensitive hydrophones listen to the deep's soundscape, a symphony of clicks, groans, and pulses we are just beginning to decipher. Every journey down reveals new wonders, and poses new questions. We have found hydrothermal vents spewing superheated, mineral-rich water, ecosystems that thrive on chemical energy instead of sunlight. We have discovered vast gardens of ancient life, cold water corals, sponges, that form critical habitats for other species. Each discovery reminds us how much more there is to learn. The work of a deep-sea biologist today is one of constant surprise, as the ocean slowly reveals its deepest, most astonishing secrets. Each animal is a marvel of engineering, a living puzzle scientists are beginning to piece together. We are not just discovering new species, we are discovering new principles of life itself. The deep sea forces us to reconsider our place and to marvel at nature's boundless creativity, which has populated even the most forbidding pockets of our planet with extraordinary life. The deep sea remains Earth's last great frontier, a place of profound mystery and endless discovery. The journey into this abyss is a journey into the heart of biological innovation. Soft breath. As we gaze into this incredible alien world, we must also consider our role as its stewards. The deep sea may seem remote and untouchable, and so far removed from our daily lives that it feels disconnected. But our actions on the surface have consequences that ripple down into the darkest depths. Pollution, plastics, chemical runoff. Deep-sea mining threatens fragile, slow-growing habitats. Fragile habitats like deep-sea corals and sponge fields that took millennia to form. Climate change is altering the ocean's chemistry. As waters absorb more carbon dioxide, they become more acidic. Acidification can devastate creatures with shells or skeletons. Warming changes ocean currents and shifts nutrient distribution, disrupting the delicate food web from surface to seafloor. These fragile places are incredibly vulnerable to human-induced change. Let us look upon the deep sea with a profound sense of wonder. Anglerfish, patient, glowing lure. Snailfish, thriving under crushing pressure. Sharks, sensing faint sparks of life in the sand. Squid, silent, luminous conversations painting the night. The deep is not an empty void. It is a vibrant, living world. Alien architects building life in ways we barely understand. The more we learn, the more we see how precious and unique this realm is. The ocean keeps secrets, stories of survival and adaptation. We have a responsibility to learn and to protect. Let us remain curious. Let us be careful. Let us cherish and protect the silent, wondrous world just beneath the surface.